Ever wondered how Red Bull is made inside the massive factories that produce billions of cans every year for people all around the world? What looks like a simple silver and blue energy drink is actually the result of highly advanced beverage engineering, precision chemistry, automated robotics, strict hygiene systems, and ultra-fast production lines running non-stop day and night. Every can must taste the same whether it is sold in Tokyo, New York, Dubai, London, or Karachi. The flavor, caffeine level, carbonation, sweetness, color, and shelf life all need to remain perfectly consistent on a global scale. The process begins with the most important ingredient in the drink, water. Since water makes up the majority of the beverage, factories use extremely sophisticated purification systems before production even starts. Ordinary tap water cannot be used directly because minerals, bacteria, microscopic particles, and chemical impurities could change the flavor or reduce product stability. Inside the factory, the water passes through multiple purification stages, including mechanical filtration, activated carbon systems, reverse osmosis membranes, ultraviolet sterilization, and mineral balancing equipment. The purpose is to create ultra-clean, chemically stable water with the exact same quality every single day. Once purified, the water is stored inside massive stainless steel tanks under hygienic conditions until mixing begins. At the same time, the factory receives the active ingredients that give Red Bull its famous energy effect and recognizable taste. These ingredients arrive in carefully controlled batches and are tested inside laboratory facilities before entering production. Technicians examine purity, chemical composition, moisture levels, and microbiological safety. One of the most important ingredients is caffeine, which acts as the primary stimulant in the beverage. The amount of caffeine added must be extremely precise because even small variations could affect the drink's consistency and regulatory compliance. Taurine, another major ingredient, is also prepared under pharmaceutical-grade standards. In addition, the drink contains sugars or sweeteners, citric acid, flavor compounds, preservatives, and B vitamins such as niacin, vitamin B6, vitamin B12, and pantothenic acid. All these ingredients are stored under controlled environmental conditions to maintain stability and freshness. Once the ingredients are approved, the syrup-making process begins. Giant stainless steel mixing tanks combine purified water with sugar and flavor ingredients. Industrial mixing systems continuously stir the liquid to dissolve everything evenly. Temperature is carefully controlled because excessive heat can damage sensitive flavor molecules, while insufficient heat may prevent proper dissolving of sugar. Sensors inside the tanks constantly monitor sugar concentration, density, acidity, and viscosity to ensure that the syrup matches exact production specifications. The result is a concentrated flavor base that forms the heart of the drink. After the syrup is prepared, the factory adds the functional energy ingredients. Computer-controlled dosing systems inject precise amounts of caffeine, taurine, vitamins, and acids into the mixture. This stage is critical because Red Bull's identity depends heavily on maintaining an exact chemical balance. Factories use automated systems instead of manual measuring because production occurs on an enormous scale, and consistency must remain perfect. Every batch is sampled repeatedly during mixing to ensure the concentration of active ingredients remains within strict limits. The beverage then moves into massive blending tanks where all ingredients are homogenized into a completely uniform liquid. High-speed industrial mixers ensure that every molecule is evenly distributed throughout the batch. If mixing were uneven, some cans could contain a stronger flavor or different caffeine levels than others. Engineers monitor mixing speed, pressure, liquid flow, and temperature continuously using computerized control systems. Modern beverage factories rely heavily on automation because human error at this scale could affect millions of cans. Once blending is complete, the drink enters the carbonation stage. Carbon dioxide gas is injected into the liquid under high pressure to create the signature fizzy sensation people associate with energy drinks. This process may sound simple, but carbonation is actually a highly controlled scientific operation. The beverage must first be chilled because colder liquid absorbs carbon dioxide more effectively. Specialized carbonation chambers regulate gas pressure, temperature, and liquid flow speed simultaneously. Too much carbonation could create excessive pressure inside the can, while too little would make the drink feel flat and lifeless. The factory carefully adjusts carbonation levels until the beverage achieves the exact mouthfeel and texture required by the brand. Before filling begins, the entire production line undergoes strict sterilization procedures. Beverage factories operate under food-grade hygiene standards, similar to pharmaceutical manufacturing environments. Tanks, pipes, valves, and filling heads are cleaned using automated CIP systems, which stands for Clean-in-Place Technology. Hot steam, chemical sanitizers, and sterile water circulate through the equipment to remove contaminants and bacteria. Even the air inside certain filling rooms is filtered and controlled to minimize microbial contamination. Hygiene is essential because contamination inside a beverage factory could ruin enormous production batches and create major safety risks. Meanwhile, the aluminum cans are manufactured separately in specialized can production facilities. Large sheets of aluminum are rolled, cut, stretched, and shaped into cylindrical cans using high-speed industrial presses. The cans are then coated internally with a protective lining to prevent the acidic beverage from reacting with the metal surface. Externally, the famous Red Bull branding is printed onto the cans using precision printing systems. The final cans must be lightweight yet strong enough to withstand internal carbonation pressure and long-distance transportation. The filled beverage now moves toward one of the fastest and most impressive stages in the factory, the canning line. Empty cans race along conveyor systems at incredible speed. First, they are rinsed and cleaned before entering the filling machines. The beverage is filled into cans under controlled pressure conditions to preserve carbonation. Modern filling systems can process tens of thousands of cans every hour with astonishing accuracy. Sensors monitor fill level, temperature, pressure, and foam formation in real time. If a can receives too much or too little liquid, it is automatically rejected from the line. Immediately after filling, aluminum lids are attached and sealed using high-speed seaming machines. These machines create airtight double seams that lock the can securely closed. The quality of the seam is extremely important because even microscopic imperfections could allow gas leakage or contamination. Factories inspect seam quality continuously using cameras, pressure testing systems, X-ray inspection equipment, and computerized analysis tools. After sealing, some batches undergo stabilization treatments, such as tunnel pasteurization or controlled thermal processing, to improve shelf life and product safety. The cans are then cooled gradually to stabilize internal pressure and preserve carbonation quality. Cooling systems also help prevent condensation problems before packaging. Quality control continues throughout the entire manufacturing process. Laboratory technicians regularly collect samples from production lines and test them for caffeine concentration, acidity, sugar levels, carbonation, flavor consistency, and microbiological safety. Advanced analytical instruments compare every batch against strict company specifications. Taste testing panels may also evaluate random samples to ensure the beverage maintains its expected sensory profile. Next comes inspection and coding. Automated vision systems scan every can for dents, label defects, incorrect fill levels, and printing errors. Laser coding machines apply production dates, expiration information, and batch numbers to each can for traceability purposes. Defective cans are instantly removed from the conveyor system without slowing production. The finished cans are grouped into packs using automated packaging machinery. Some are wrapped into 4-packs or 6-packs, while others are packed into larger trays for supermarkets and wholesale distribution. Robotic palletizers stack cases onto pallets with precise arrangement patterns to maximize shipping efficiency and prevent damage during transportation. Finally, the completed pallets are transferred into giant warehouses where conditions are carefully controlled to preserve flavor and carbonation quality. From there, trucks, cargo ships, rail systems, and international logistics networks distribute the product worldwide. Within days, cans produced in one factory may appear on store shelves thousands of kilometers away. What seems like a simple energy drink is actually the result of advanced chemistry, food science, industrial engineering, robotic automation, and precision quality control systems working together continuously at a massive scale. Behind every can of Red Bull is a highly sophisticated factory operation designed to produce billions of identical drinks with incredible speed and accuracy. And that is how Red Bull is made inside the factory that powers the world.